Hey guys, this is our first mini episode, and on this one I wanted to dispel some myths about carburetors, namely your idle mixture screws and what happens when you move them in and out. I hear a lot of people say things like, oh, I've got to give it more fuel, and they turn the mixture screws out and it works, but they don't know why. This is geared towards Holley style carburetors. This is an 850 double pumper with 4-corner idles, but that's just because this is what I'm most familiar with. On any carburetor though, your fuel has to start in the float ball. And on a Holley, in order to get out of the float ball, this is the side of the metering block that faces the float ball, it has to go through the main jets and the power valve, but we're going to ignore that, for the idle circuit at least. And that's the first thing that I hear people say, is that the main jets have no effect on idle fuel. They do. Whether it's enough to make a practical difference is pretty debatable, and I would say this is more of a theory thing, but you do have to flow through the main jets in order to get into the metering block. And your next orifice that really is controlling your fuel is here, your idle feed restrictors. On a stock style carburetor, they are pressed in, they're not changeable, but they basically are an orifice that meters the amount of fuel available to the idle circuit. And your fuel then kind of goes up, and it meets up here in the main body with, I'll show you this on the secondary side because it's easier to see, there's no choke. You have 4 air bleeds, 2 high-speed air bleeds and 2 idle air bleeds. And up until this point in time, it's been all raw fuel, but once the fuel comes up and meets those air bleeds, it mixes with air, and everything from this point on is a mixture of air and fuel. And I think that's the biggest misconception most people have. They think that when they're turning your idle mixture screws, you're controlling the amount of fuel the engine gets, and you're not. You are controlling the volume of a predetermined, pre-mixed mixture of air and fuel. And I want that to be your big takeaway here. And so that mixture comes down and you get into these ports here, which go to your idle discharge port and your transfer slot port, and they match up to the carburetor main body on those 2 ports right there. And where that magic happens is in the throttle bore. You probably can't see it, but I will put up a picture of this so you can see. But there's a transfer slot. It's a slot, vertical slot cut into the bore of the venturis. And at idle, that transfer slot needs to be a perfect square. And then there's a little hole down there also, which is your idle discharge port. So at idle, with the transfer slot as a perfect square, all of the fuel and air that the engine is intaking comes, or that mixture rather, is coming through the idle discharge port underneath the throttle blade. And the reason this is important is because that transfer slot is used as transitional fuel. When you roll the throttle open, it exposes that transfer slot, and it allows some of that idle fuel and air mixture to be introduced to the engine to cover up the sudden influx of air that occurs when you open the throttle. And a lot of people think only the accelerator pump does that, but they're wrong. That transfer slot is very important. And why this is all important is that on a stock engine with a small cam in it, you can probably put a carburetor on and set your transfer slot to be a square and your idle mixture screws to be 1.5 turns out, and it'll crank up and run. On an engine, a high performance engine with a big single plane intake manifold and a big camshaft or something like that, where you don't have a lot of signal underneath the carburetor, it probably won't idle. And most people just go straight to your idle speed screw over here and just turn the throttle plates open until it does. The problem with this is that you then overexpose the transfer slot and you lose that ability to have that transitional fuel, and you now have a really big bog because you've deleted the transfer slot from the equation. So what do most people do? Well, a hesitation on a carburetor, you need more accelerator pump, and they just drown the thing in accelerator pump fuel. So the end result is you end up with idle mixture screws that are probably non-responsive. Ideally, you want your idle mixture screws to operate between 1 and 2 turns out, and you also want them to be pretty touchy, pretty, sensitive to adjustments. That's how you know you've got it pretty good. So if you crank that idle speed up, you end up with unresponsive idle mixture screws, you delete the transfer slot, you drown the thing in accelerator pump fuel. It's not going to have good fuel economy because you can't adjust your idle mixture for lean best idle, and it's gonna not be as snappy and responsive as it could be if you had the appropriate accelerator pump in it. And that leads me to, if you are looking for an aftermarket carburetor, look for something that these circuits are adjustable. They're not just pressed in orifices. A lot of aftermarket carburetors, especially the ones with billet and aluminum construction, feature removable bleeds or restrictors. And they're little brass jets that you can screw in and out. I really like the Holley Brawler line. That's a really affordable carburetor that features a ton of tunability. So I hope you took something away from that and learned something. That's really it.